imagine a country where charging your electric car is just, well, as easy as using your phone, and where cities are just buzzing with new EVs. That's China. And today, we're diving into how they pulled off this huge change. It's not just about the cars themselves, but the whole system, the infrastructure, the policies, the tech that made it happen.
Yeah, it's a fascinating story. We've looked at recent news, official reports, policy deep dives, and even some pretty critical academic research, especially on the environmental side. So our mission today is to really unpack the scale of China's EV revolution, understand the rules that pushed it forward, look at the innovations, and yeah, maybe look at some environmental aspects that might surprise you.
So whether you're just curious about what's happening globally, maybe prepping for a meeting on clean energy, or you just want to feel in the loop, you're definitely going to find some aha moments here. Okay, let's get into it. How did China go from, roads full of bicycles in the 80s to being this global EV giant? It feels incredibly fast. It sounds like there must have been a really big top-down plan involved.
Oh, absolutely. It didn't happen by accident. The change has been amazing, and it's definitely built on a very deliberate policy foundation. It actually started pretty early. Think major EV subsidies way back in 2009, 2010. But the real kicker, that was the new energy vehicle, or NEV mandate. They announced it in 2015, rolled it out fully by 2019. And this wasn't just encouragement. It required car companies to make and sell a certain number of EVs.
Required, so not just a gentle nudge, but actual targets.
Yeah.
And they used something called a dual credit system to enforce that. How exactly did that work? What did it really do?
Exactly. Yeah. Think of it like a market mechanism with teeth. Car makers got credits for making NEVs and lost credits, essentially got penalized, for making too many gasoline cars. If you didn't meet your NEV target, you had to buy credits from companies that exceeded theirs. So it created this really strong economic push, a penalty for falling behind, a reward for getting ahead. It basically forced the whole industry to move, and fast. And it wasn't just about making the cars. There were incentives for buyers, too. National purchase subsidies, okay, those ended in 2022. But the purchase tax exemptions, those are still running right through 2027. Makes a big difference to the price. Plus, lots of local governments add their own perks. And then there's the bigger picture. The 14th five-year plan, that's 2021 to 2025, specifically set out to build the world's biggest charging network. It was like an all-hands-on-deck situation. State companies, public transport, all pushed towards electric. Think public buses, taxis, they went electric really quickly. Cities offered help for installing chargers. And crucially, they did two things. Standardized to one plug type makes life so much simpler for drivers. And since 2015, in new public buildings, 10% of parking had to be set aside for charging. Some cities even required more.
Wow, that level of coordination is something else. It really does sound like a central plan moving mountains. But does that kind of centrally planned approach affect things like innovation or maybe the experience for the driver compared to, places where the market leads more?
That's a great question. And it really makes you think, doesn't it? For any country wanting to speed up EV adoption, how important is that kind of clear, consistent, government-led strategy? China's experience seems to say it's absolutely vital, not just setting goals, but orchestrating everything, manufacturing, charging, getting people to buy in.
Okay, so that vision from the top clearly set the stage.
Yeah.
Now, let's look at how that actually translated into stuff on the ground, the chargers, because this is where the numbers just get mind-boggling.
Yeah.
Truly staggering scale.
You're not kidding. It's hard to wrap your head around. Officials just announced, this was August 2025, that China has built the world's largest EV charging network, period. What that means, practically, is they've basically solved range anxiety for most drivers there, making EVs genuinely practical for everyday life, almost everywhere, which is, not the case in many other places. By the end of July 2025, get this, 16.7 million charging points. That's up 53% in just 1 year. And 10 times what they had back in 2020.
10 times in 5 years.
Yeah.
That's exponential. That kind of growth isn't just about money, right? It implies huge changes in how people use cars, how cities are built. How do they manage that speed? What are the big challenges?
It's just relentless building. In the first 7 months of 2025 alone, just 7 months, they added almost 3.9 million chargers. That's a 93% increase compared to the same period the year before. Just incredible. And that includes both public chargers, over 600,000 new ones, and private chargers for homes and workplaces, over 3 million of those. So, coverage everywhere. And here's a key stat. The ratio of chargers to new EVs being sold is about 1 to 1.8. That means the infrastructure build-out is actually outpacing the vehicle sales growth. They're staying ahead of the curve. Just for perspective, in 2022, China built 650,000 public chargers. The entire U.S. built, what, maybe a tenth of that? Guangdong province alone had more than double the number of public chargers than the entire United States.
Wow, those comparisons really put it into perspective. So it's not just throwing up chargers everywhere. It sounds like they focused on making it easy for the driver, too. A smooth experience.
Absolutely. That's key. And the tech helps. 40%, almost half of their public chargers are fast chargers. That means you can get a decent charge in, say, 20 minutes. Huge difference for daily driving or trips. And the payment, super simple. QR codes. You use apps everyone already has, like WeChat or Alipay. No messing around with different cards or memberships like you often see elsewhere. Scan, pay, charge. Really seamless.
Okay, so no more pulling up to a charger and realizing you don't have the right app or card. That alone sounds like a massive win. Less frustration.
Definitely. And all this charging naturally uses a lot of electricity. Consumption for charging and battery swapping grew over 40% in the first 7 months of 2025. In July 2025 alone, we're talking about 7.7 billion kilowatt hours just for charging. What's interesting, too, is who runs these chargers. While the government set the direction, it's mostly private companies now. Players like TelD, StarCharge, Yunkuo Charge, the top 15 operators manage something like 84% of the public chargers. Plus, the big EV makers, NIO, Li Auto, Tesla, they're building out their own networks, too.
So for you, the driver in China, this massive build-out, really cuts down on that range anxiety, right? That constant worry about finding a charge. It just makes owning an EV a much more practical, everyday thing.
Yeah.
Okay, so they built the network, people are adopting the cars. What does all this mean for China's place in the global car industry and its energy use? And are there any really cool new technologies coming out of this huge effort?
Well, first, it clearly cements China's leadership. It's the biggest maker and buyer of EVs globally. You've got domestic giants like BYD and NIO leading the charge, and this huge market, this whole ecosystem has pulled in international players. Tesla built a massive factory there. Other global car makers are designing EVs specifically for the Chinese market now. Some of those then get exported too.
Right, so it's shaping the global market, not just the domestic one. And energy-wise, how are they powering all these millions of EVs? That's a lot of new demand.
That's the crucial link. They've also been pushing hard on renewables. During that same 14th five-year plan, renewables went from about 40% of installed power capacity to roughly 60%. That shift is absolutely vital. You need cleaner energy sources if you're adding all this electricity demand from EVs. And on the tech front, vehicle-to-grid, or V2G, is really interesting. The idea is your EV isn't just a consumer of power, it can also be a supplier, like a mobile power bank. It can send electricity back to the grid when demand is high. This helps stabilize the grid, and potentially owners can make money from it. We saw this example of a NIO owner in Shanghai. They were earning around 500 yuan, maybe $70 a month, just by charging their car when power was cheap, off-peak, and selling it back during peak hours. Apparently, they discharged over 15,000 kilowatt hours back to the grid over time.
Wow, that's clever, turning your car into an energy asset. But hang on, what about the battery? Doesn't all that charging and discharging wear it out faster? That's always the worry.
It's a valid concern, yeah. And they're tackling it in a few ways. NIO, for example, has this battery as a service model. You lease the battery, you don't own it, and they offer battery swapping. Plus, the leased batteries often come with lifetime warranties. So the degradation risk isn't really on the owner. There's also, a better understanding now of different battery types. Some, like ternary lithium, give you more range. Others, like lithium iron phosphate, or maybe less energy dense but super durable, last thousands of cycles. So manufacturers can choose the right tool for the job, and honestly, people in China tend to replace cars pretty often now, maybe every 3 or 4 years. So super long-term battery life becomes, well, less of a personal concern for many owners.
Okay, that makes sense. Different solutions to that battery anxiety. So looking forward, what's the goal? Where does China see this going?
The ambition is still huge. They're aiming for NEV's new energy vehicles to be about 40% of all new car sales by 2030. Keep expanding charging, obviously, and keep pushing to power those EVs with cleaner energy. And this V2G thing, it's fascinating. It could really change the game, making EVs not just transport, but active grid players, maybe even a kind of financial product for owners.
Right. Okay, so incredible progress, massive scale, cutting-edge tech. You'd think, okay, this is just a straight-up win for the environment, right?
Yeah.
Electrifying transport. But some recent research paints a more complicated picture, maybe even a surprising one. Let's dig into that a bit.
Yeah, that's right. It's not quite as simple as EVs good, gasoline bad. While yes, the huge EV uptake definitely cut gasoline use, and China's reliance on imported oil, a study looking at the period 2015 to 2020 found something interesting. It actually increased the demand for coal-fired power. Because historically, a lot of China's electricity has come from burning coal from thermal power plants.
So hold on. They reduced emissions from tailpipes, but potentially increased emissions from power plants, sort of shifting the pollution problem rather than eliminating it entirely.
Exactly, that's what this research suggests. For that period, it looked like a transfer of emissions, carbon, air pollutants from the transport sector over to the electricity sector, not necessarily an absolute cut in total nationwide emissions or pollution. And the really interesting part, it wasn't the same everywhere across China. It varied a lot by region.
Okay, tell us about that. How did it differ?
Well, in provinces that were already heavily reliant on coal power for their electricity, adding EVs did cut gasoline use and the carbon from that gasoline, but it didn't cause a big additional jump in coal burning or coal emissions. Why? Probably because their industries were already burning so much coal, the extra bit from EVs didn't move the needle drastically in that context.
Uh, that is not what I would have expected. So what happened in the provinces that started out cleaner, maybe using more hydro or other renewables?
Right, this is where it gets really counterintuitive. In those provinces with low initial reliance on coal power, the surge in electricity demand from all the new EVs actually outstripped their existing clean energy supply. So, ironically, they ended up having to burn more coal to meet the demand from the green cars, leading to a significant increase in coal consumption and carbon emissions from coal in those specific regions. And there's another layer, this spatial spillover. Electricity moves around. So, if a region imports a lot of its power, its increased EV demand might actually cause more coal to be burned in the region that's exporting the power to them.
Wow. So a city or province could feel like it's getting greener with EVs,
Mm.
but its demand is actually pushing the emissions burden onto somewhere else,
hmm
possibly even making the overall grid more reliant on coal in the short term.
Precisely. The study we looked at in Frontiers basically concluded that just pushing EVs really fast, on its own, it seems like that's insufficient to guarantee emissions cuts and environmental gains. It has to happen alongside a really aggressive push to decarbonize the electricity grid itself. It's not just about the car, it's about where the power comes from.
That really makes you think, doesn't it? When we talk about green transport, for you, the consumer, or for policymakers, how deep do we need to look? Where does that energy actually originate? Clearly, it's not always straightforward. Okay, so let's recap. We've taken a deep dive into China's huge EV push. We saw the ambitious policies, the absolutely mind-blowing speed of building charging stations, some really neat tech like VDG. But as we just discussed, it's complex, especially when you look at the full environmental picture.
Yeah, and if you zoom out, China's story really shows the power of a focused national strategy. They moved mountains fast, but it also gives us a massive lesson, really, for the whole world. Electrifying cars is crucial, yes, but it absolutely must go hand in hand with cleaning up the electricity grid. You can't have truly sustainable transport just by changing the car. You need to change the whole energy system behind it.
Absolutely. Well, we hope this deep dive left you feeling more informed, maybe gave you a few surprises along the way. If you found these insights valuable, please do hit that like button and subscribe to the channel. That way you won't miss out on future deep dives like this one. Your support really helps us keep digging up these important nuggets of knowledge for you.